Welcome everybody to GlugNet. This month we are pleased to welcome Kevin Griffin, who will be talking to us about supercharging your ASP.NET applications. A few housekeeping items before we get started here. First of all, if you're not familiar with GlugNet, we are the Greater Lansing user group for .NET developers based out of Okemos, Michigan, pictured here. And our meetings are held every month on the third Thursday and are free for all to attend. And this QR code will take you to our meetup page. If you're not already a member, I encourage you to do so. You'll find out about all the upcoming events going on, so it's a good deal. I would like to thank our sponsors this evening, NIS Technologies, who is providing us this virtual meeting space, as well as recording capabilities. JetBrains, who will be providing us a license to raffle off at the end of the night, but more information on that later. The .NET Foundation to help pay some of the bills of the organization, and TechSmith, who is our normal physical hosting site. Meetings are recorded and posted to YouTube by Sam Nasser. There's that QR code. There is a link to his YouTube site. I'll also drop a text link in the chat later on, so you can look for the recordings there, as well as see past recordings of GlugNet events. If you have questions during the presentation, feel free to unmute yourself and ask those questions, or if Kevin has any questions for us, you can certainly unmute and answer those. Otherwise, we just please ask that you remain muted so that there's no background noise and everyone can enjoy the presentation. If you don't feel like speaking up, feel free to use the chat feature within GoToMeeting. I will monitor that as well, Kevin, if you want me to, and then I can interrupt you with any questions as we get them.
Sounds good.
Okay. At the conclusion of tonight's presentation, we will have a survey. It is completely anonymous, and all that information will get aggregated and sent to our presenter so he can improve on his presentations as he goes forward with these. So very important, if you wouldn't mind filling that out and giving him his feedback. Additionally, if you fill that out, you are eligible to enter to win that personal license from JetBrains. That gives you your choice of product, including one of the suites, and updates for up to a year, at which point you can either choose to pay to continue to get updates, or you can just keep the version you land on. It's a really great deal, and we thank JetBrains for providing that for us. And now, as they say, it's time for our feature presentation.
Oh man, that graphics a blast from the past. It's like I need to remember to rewind my VHS when I'm all done, right?
That's right.
It's an oldie.
So let me make you you're a presenter here, Kevin.
Awesome. So fun fact, I have spoken physically at GlugNet long time ago. I can't even tell you when. It's been such a long time. But I remember I did a user group tour, and I think GlugNet was my last one of the series. So it was a very long time ago. I should actually have looked. I should have looked up the dates, because it would have been nice to know last time I spoke with all you fine people. So thank you for coming out or watching the replay a little bit later. It's a beautiful was it Thursday night where I am. I'm in Norfolk, Virginia. Just kind of enjoying. We're getting some warm weather coming through, and I've heard some of you folks up north are getting snow. So hopefully no one here is impacted by that, because I think that would be horrible to have snow in April. I cannot think of anything worse weather-wise, right? So awesome. Well, make sure you're all in the right place. This is Supercharge, your ASP.NET Core applications. A little bit about me, if you've never seen me before, or we've never had the pleasure of meeting. My name is Kevin Griffin. I'm a Microsoft MVP. My primary focus for the past 15 so years has been in ASP.NET and more recently ASP.NET Core. and deploying web-based solutions to Microsoft Azure. If you've ever like to talk to me afterwards, feel free to hit me up on Twitter, or you can go to my website, consultwithgriff.com, and I'm usually posting stuff there occasionally. I also have an amazing course on Signalr. Is actually one of the topics that we'll talk about in this session. But if you'd like to learn more about Signalr, I have a course called Signalr Mastery that will teach you almost everything you need to know to become a Signalr master, building real-time web applications on the .NET platform. So this talk came from a bunch of talks I used to do on ASP.NET Core, where I like to talk to folks about features they might not be aware of in the ASP.NET platform, and then more recently the ASP.NET Core platform. And I also am continuously meeting people moving to the ASP.NET Core for the first time who might have been supporting ASP.NET like full framework applications for the past 10, 15 years or so. They're making this move to Core, and they want to learn about some of the new stuff that we can do in Core that they might not be aware of. And the thing I really like to say about ASP.NET Core is it's like a box of trail mix. You have all these goodies in there, and you have the stuff that everyone knows about, all the fancy bells and whistles, the M&Ms, so to say. But there's also some little like good pieces in there, like the raisins and the cashews maybe. And depending on where you're getting your trail mix from, there might be little bits of peanut butter that you might not be aware of. I think of ASP.NET Core kind of the same way. There's the stuff we see all the time. If you've paid attention to a build or a .NET Conf presentation, they show you the cool, fancy things that they're trying to push you towards. Like you're probably aware of Blazor, and I'm not going to talk about Blazor because I don't think Blazor is interesting. I want to talk about things that I see people actually using out there in production systems that are new to ASP.NET Core. So we're actually got 4 that we're going to cover tonight, and the first one is a feature. It's been in for a while now, but it was new in ASP.NET Core. It's this concept of health checks. And here's how we talk about health checks. When your application is exposed out there on the internet, it might live out there by itself, but it might also have a couple dependencies. For example, it might talk to a SQL server. You might talk to Azure Storage. You might talk to Redis. You might have any number of external dependencies that are required for your application to work and do the things that it necessarily needs to do. And when all this stuff is working, and it's working in the quote best possible way, we consider this a healthy application because the requests are coming in, we're able to go to the resources that we need, we get the responses that we're expecting, and everything's good to go. But there are cases where stuff happens, and this is stuff outside of your control. Like maybe the SQL server that you're running on is gone down for a maintenance mode. So for a period of time, it's just unavailable. And if you don't have any sort of replication set up or not, it's just down. Well, that means your application is down. And I've run into this a number of times with a variety of different applications where one of our dependencies that we're expecting 5 nines of uptime, it's that moments that we don't have that uptime, that something serious happens and we're not expecting it. And our application goes hard down because its dependencies are hard down. And then when this happens, we actually get into a new state that we just call unhealthy. And it's useful to us to be able to get a bird's eye view of how our entire application is working at any one moment, and is the entire application healthy, or are bits and pieces of it unhealthy. And you can also have cases where something goes down and it doesn't necessarily affect the healthiness of an application. Use an example like Redis. If Redis goes down and I don't have access to a caching layer, That's not necessarily an unhealthy situation. I might have a case where, all right, if Redis goes down, we'll just go straight to the database for all of our data access. We don't need to worry about caching layer. The application can still work in those moments. But if SQL Server goes down hard, that's unhealthy. We just can't work when that's the case. So in ASP.NET Core, this was kind of introduces a feature of health checks. Is the application healthy or unhealthy? And what combination of things need to be checked in order to determine that state? And in our startup CS, we actually can go through and set up this configuration. You don't have to install any special NuGet packages. It's built into the core project if you're running at least ASP.NET Core 3.1 and higher. But we could go into our startup and tell ASP.NET Core that we want to add health checks. And then there are a variety of different types of checks that we can use. And we can also write our own. So a lot of the ones I'm using here aren't even supported by the ASP.NET Core framework by default. They're actually a third-party offering that's built all these great tools on our behalf. We'll walk through in a moment setting up all the different health checks and seeing what the output looks like. But how do you actually get to this information when you want to know, is the application healthy or not? Well, we can set up an endpoint, and endpoints are pretty straightforward. We go down to our configure method and say, all right, I want to use the endpoint health, and when we access that endpoint, I want to get the current health of the application. Now, I talked about the third-party health checks. So this is a great library, and I'm recommending it to you because it's recommended in the ASP.NET Core documentation. So this is a blessed version of a library that gives you all kinds of different health checks. And what I'm going to do for fun is, since we're all live here, I'll go to that GitHub repo and just show you some of the things that we could search for. Let's scroll down, and there's a lot of packages here. So no matter what third-party dependencies you're using, there's probably a health check already built in for them. So I do a lot in Azure, but if you're out there on Amazon or AWS, there's several packages for, say, checking S3. If you're doing anything with Cosmos or DocumentDB or DynamoDB, if you're using Mongo versus MySQL versus Postgres, all your databases are covered as well. And we can go down this list and say, hey, there's even a Signalr endpoint. Or you could just check for different URLs that are up. This is one in particular that we use in one of our production applications, where we have a third-party discourse forums system that we kind of expect to be up all the time. And we have an endpoint over there that will tell us 200 okay, everything's up and running, or there's an issue on the forms that we need to be aware of. So we'll set up a health check that just points to that URL. And anytime we need to periodically check the health of that application, it goes and hits that endpoint. So no matter what third-party stuff you're out there using, there's something in here for you to use. You could also write your own, which I think I have an example of. So let's jump into a little bit of code. Actually, I don't think I have an example of that, but so I have an application here. Let's bring up my startup CS. So this is an app that's gone through a couple upgrades of .NET Core. It originally started with .NET Core 3.1, and now it's running on .NET Core 6. But nothing's really changed there, so we're good to go. There's a couple of things I'm setting up. I'm adding health checks to my application, setting up all the proper dependency injection. I'm telling the health checks that I want to check for a SQL Server database to be available. And if it's not, that's going to cause a problem. And then I have a custom health check I've built called "Is the website up?" And it gets its own little proper name, "Is website up?" If you wanted to build your own, and I actually don't recommend this because the third-party packages has so many different options, but if you absolutely had to, you have something internal, we could go build our own by just creating a class that implements the iHealthCheck interface. And one of the things I do here is I inject an HTTP client, because all we're going to do is go hit a URL, see whether or not it returns 200 OK. And if it does, how long did it take for that request to respond? As I said a moment ago in the slides that you either have healthy or you have unhealthy nodes. But there's also a kind of a middle case where you're going to have a degraded node. So it's working, it's just not working up to par, and whatever that par might be. So for our custom health check, we're going to go get content of a URL. And when it comes back, we're going to see, was it successful? And did the amount of time that it took to go get that response, did it take less than 2 seconds? If it did, awesome, everything's running fine. If it's more than 2 seconds, but still successful, we're considering this a degraded state. Everything's fine, but something might be a problem because we're not responding as quickly as we would have expected to. And then finally, if there's no success, so we get 400, 500, something bad from the server, we're going to respond with unhealthy, that the website is not responding correctly. Over on the configure method, so actually setting up the endpoint that goes to do the health check, I have a mapping here to map health checks to the endpoint /health. And then whenever this gets called, I'm going to send back a slightly better formatted response. So I'm actually going to do this in 2 ways. We'll go ahead and remove all that stuff. We'll just return the normal default response first. And we'll go into our code. We'll say .NET run. Open this up in a browser. All right, hello world. And I'm going to say health. It's going to come back unhealthy. Wow, that's actually a problem. What is causing it to be unhealthy? Well, if I could look at the logs, I can see, oh, well, there's a problem with my SQL server. But how would I know that just if I didn't have access to the logs immediately? Let's go into our health check. And I'm going to drop in the options that I had originally. The specific one that we care about is this response writer. And again, this is built into that health checks library I showed you a moment ago. It's going to take all the data from the health checks and it's going to parse it as a JSON object. So anything that's reading this, whether it's application insights, any other telemetry that you might have, it can read this JSON and actually determine some logic from it. Let's save this, go back to our code, and we'll restart that application. I'll refresh this page, and we'll see I have a better formatted document here. So we're unhealthy. Website is up, it's working great. Duration, very quick. We're not worried about that. But the SQL server over here is throwing an error because it can't open a database. Well, that actually makes a ton of sense because I don't have that database on the system. So let's fix that real fast. I'm going to go over into my SQL server. I want to create that database. Boom. I do need to check the, yep, I need to check this. So give me 1 second. So this is demos. There we go. That should work. We'll restart our system. We'll give this another try because we want that healthy. So let's go ahead and, yep. So here we go. We're back to a healthy state. The total status is healthy and the individual nodes are healthy. So I highly recommend this for as you're building up your applications and you are identifying these various third parties dependencies that you have to talk to. Set up healthy nodes for them So if you need a just overview of what's healthy and unhealthy in your environment, this is a great way to do that. I'm also not a Docker container guy, but if you are, there are various ways to tie health checks into things like Docker. So if something's going unhealthy, you can recycle the instance automatically and always keep things up and working. All right. Oops. Oh, go away, go away. All right. Let's jump into Supercharge tip number 2, and that's background workers. There's a lot of things that I do or need to do in the background of an ASP.NET Core application, or really any web application in general. You might need to send emails, you need to process queues, you might need to clean up storage. You might just have general processing that needs to occur. And you don't want that work to happen at the moment, say, an API endpoint gets called. You want to delay that work and perform it at a later time. There are a bunch of different ways to implement background tasks. One of my favorite ways is to actually just use Azure Functions, and we do most of that work in our Azure Functions. You could also use something like Hangfire. Hangfire is a great solution. There's Quartz, which is a scheduler built for .NET. But recently, as of a couple versions ago, ASP.NET Core added the concept of background workers. And this is not even just a .NET or ASP.NET Core feature, it's a .NET feature. So if you're just building a .NET 5, .NET 6 application, a service, you could use background workers in those independently. It doesn't have to be ASP.NET Core. Now I talked about all the custom tooling. So the way this works is in our ASP.NET Core application, we're going to create what's called a hosted service. There's 2 ways to create hosted services. There's the background service implementation, which I prefer if you're building something that's just super easy, because you don't have to do a lot of the setup and management of the background service. But here's a case of I have a class, implements background service, and I can take full advantage of the dependency injection pipeline for ASP.NET Core. And then when my application starts up, the execute async method gets called, and it's just going to work as long as I need it to. If that method were to return, your service is done running. But notice that it's passing in a cancellation token. So we could technically sit this in a loop and keep pulling queues, pulling different services, keep doing whatever we need to do until that cancellation token requests the application to stop. The other way that we can build the background service is using the iHosted service implementation. Still can take advantage of ASP.NET Core injection, but instead of us having to just worry about one method, we have 2 methods. There's start async and stop async. So we can start doing our work, and then later if ASP.NET Core or .NET Core wants to shut down our service, there's a separate stop call that gets called a little bit later. I've seen a ton of examples where folks will start a timer in start async, and they'll just wait for an interval and they'll do some work. And they'll just keep doing that forever. So these services are basically singletons. They'll run indefinitely until your application crashes or it requests a stoppage. These are easy to configure in your startup CS by just adding a hosted service and giving it the type of your service. ASP.NET will automatically worry about setting this up and running it. So there's nothing that you necessarily need to do to make this work once you've written that initial class. And like I said before, I have a demo. So let's jump into my workers demo. Go to meetings in the way, get out of the way. All right, get out of the way, go to meeting, there. All right. So we'll go in our startup CS. we see here I'm adding a hosted service that is called Generate New User Worker. Of course, you can call it whatever you want to. The new user worker I'm creating implements background service, and it's going to take a couple injections. And again, this can be anything that you want to inject. That's injectable. I'm injecting HTTP client factory because I want to use an HTTP client a little bit later on. And I also don't want to hold on to an HTTP client indefinitely. So I want to make sure that I'm only allocating one when I need to make those calls. I'm also passing a logger because technically you should be logging everything. I'm bad about that. Hopefully you're much better about it than I am, but we'll inject a logger. When our application starts, it's going to eventually start the background worker, and we're going to wait about 10 seconds. Now, this is probably not the best way to do this, but it's a demo. And every 10 seconds, I'm going to check to see if my cancellation token has requested a cancellation. If it hasn't, we're going to just keep acting like everything's normal. I'm going to go off to another service, another dependency, and I'm going to generate a quote new user. We'll log some information out to our logger, and we'll wait another 10 seconds and do it all over again. Now, get user, this is kind of fun. It's talking to a service called randomuser.me, which if you've never played with it before, you should totally play with it. It's a great little API. And they only have rate limiting. I've hit this thing hard a couple 100,000 times, and it just keeps going. All you have to do is hit the URL randomuser.me/API, and it's going to give you the metadata for a random user. There's a lot of metadata in there. So we go get that data, we parse it into an object, and we return that object. Rinse, repeat over and over and over again. So if I go into my console, I'm actually going to bump the font up on this one a little bit. We'll say .NET run. Oop, I have an error. Ooh. Oh, it's because I'm running over here. All right, let me try that again. Nope, that's not what I wanted. .NET run. And there's no fancy UI here. We're just looking at the logs. So remember, it's going to start up. It's going to wait about 10 seconds. And every 10 seconds, you'll see it getting a new user. And that new user, Gabriella Strecker. Wait another 10 seconds. It'll give me another new user. So this one had Unicode characters. That's why they're showing up as dollars or as question marks, because terminal can't actually render them. That's weird. Marina Iglesias. So every 10 seconds, the background worker is going to go off and do this work for us. So I use background workers often for things that I need done within the realm of my ASP.NET Core process, but I don't want to tie up any of my, say, endpoint processors. So background workers, great for that sort of thing. If you have something that's computationally heavy, probably not the best place to put it is in a background worker. You probably want to go look at, say, an Azure function or some sort of external service for your background workers. But if you have something that can be done quickly, do it inside of a background service. All right, let's shut that down. Now, I said before that there's no UI to this, but here in a moment, we'll actually talk about a UI. All right. We're about midpoint. Any questions? Chat looks empty, so I'll take that as a good sign. All right. Well, number 3 on our list, and we're going to keep going through these, is Signalr. And Signalr, by far, is one of my favorite subjects to talk about. I did an entire course on Signalr because I loved talking about it. I loved teaching it. And I've been talking about Signalr for about 10 years now. Yeah, we're coming real close up to the anniversary of the first version of Signalr a long time ago. So signalrmastery.com, you should go buy it. But let's talk about what Signalr is. So I want to walk through just a concept with you. Let's imagine we have a server and we sell widgets, and all of our widgets, we have an inventory. Say at the moment we have 10 widgets, and we have a variety of people that are looking at the site at any moment. We'll call them clients A, B, C, D, E, F, and client A goes to the site and says, hey, how many widgets do you have? It gets back some rendered HTML that says, hey, there are 10 widgets currently in stock, and there's a whole bunch of other stuff in there. And that page just stays up on the person's browser. At the same time, client E goes to the server and asks the same question. How many widgets do you currently have in stock? And it gets back the same HTML, give or take, that there are 10 widgets currently in stock. Awesome. Well, client A decides at that moment, I want to go buy all 10 of these widgets. And the server says, great, goes through its motions, and the inventory now becomes 0 in the back end. Awesome. Client A got exactly what they wanted. There was no issue with the state of the server. Client E, on the other hand, says, well, I don't want to be greedy. I don't want all 10. I just want 2. I want to buy 2 widgets. Well, the server comes back and says, no, I'm sorry, I can't do that because I have 0. And client E, as far as they're concerned, there are 10 widgets because that's what they got back from the server just a moment ago, a couple of moments ago. So that's a problem. We have to do this validation, and you should do that validation regardless. I'm not telling you not to validate the orders when they're coming through, but it would be really nice if client E just knew that the widgets had been purchased and that there was an update. Well, let's recycle this concept and let's talk about a little bit better approach to solving it. Instead of clients A, B, C, D, E, and F all going and getting individual pages, they're going to go to the site, they'll load the site, and they'll create what's called a WebSocket between all of the individual clients in the server. And this is an end-to-end connection. So the clients can send information up to the server can send information down to the clients over the same pipe. And they all get the same information initially. Hey, there's 10 widgets in stock. Client A is going to issue its buy for 10. The server is going to update its inventory to 0. But now that it knows that the inventory is 0, and it has a mechanism to alert others that the inventory is 0, it can send that message out to everyone else that needs to know that the inventory has been updated to 0. So they can all get that notification. And the best part about that is E, now, if they're getting ready to hit that buy button, they'll get an update to their screen that says, sorry, we're all sold out. Go do something else. So it's an excellent way to push state changes from your server out to all your connected clients. And I use the word clients loosely. Like I typically use it in the term of a web page. My web server is talking to a web page, and it's going to keep the state up to date on that web page. But it doesn't necessarily need to be a web page on a server. It could be a mobile app. So if you're building something with Xamarin, still.net, or you're building a mobile web app, say a progressive web app that you're installing onto a browser or a mobile browser, that all is still a client. If you're working with IoT devices, those are technically clients as well. And there's a lot of great Signalr examples out there where people talk from devices, say maybe getting temperature or the state of a camera, and they're sending it from Raspberry Pi to a server and vice versa. The best part is that this is all .NET. So the server aspect itself is .NET, but the clients can be JavaScript, it can be .NET, it could be Ruby, it could be Go, There's even a C++ client for Signalr. So I can keep talking about it. I do have an entire course on this subject, but let's show you a quick example of Signalr in action. We're going to take that worker example that I just had, generate new user worker, and we're going to build a very small UI around that. So let's look at our startup to see if anything's changed. We still have our generate new user worker hosted service, but you can see up here I'm adding injections for Signalr. So I want to do the end-to-end connection between the client and the server. Nothing's really changed to configure. I'm going to have an index.html file I'll show you in a moment. And then I'm going to send an endpoint for Signalr, which I'm calling the sync hub. And the sync hub just syncs the state from the server to the individual clients. You can name the sync hub or anything you want to. We use this concept of a hub it's kind of like a transportation hub. It's where everyone connects. So your sync hub, or whatever you want to call it, it knows about every single connection to your server. It could be every web browser, every tab, every Raspberry Pi, every mobile device. All those connections go through this hub. So this hub knows about everyone. And there's a variety of different ways to use a hub. The way that we're going to use it is that a person, no matter what client they're on, they can subscribe to state changes. So anytime a new user is generated, we can send that notification to someone. So we're basically putting people into this big group called Notify Me. Notify me when there's a new user. Or if you don't want the notifications anymore, you could remove me from the group, Notify Me. So I'll stop getting those notifications. Every connection, whether it's a tab or window or Raspberry Pi or mobile device, they all have their own unique connection ID. And we can ask ASP.NET Core to track all that stuff for us independently. Over on our index, this is a very simple web page. It's going to have a button on it, start and end. And I'm going to have this unordered list that I'm calling new users. We'll have a little bit of JavaScript. If you're doing a web page with Signalr, you're most likely going to use TypeScript in some sort of build system like Webpack, or say Vite is kind of the new hotness, but you have like create React app, you have the Angular CLI, or you have the Vue CLI. You're using one of those build systems that will do a lot of the heavy lifting for you. This example, I just did an npm install and pulled the pre-built JavaScript into the page. But basically what we're doing is we're creating a new connection to our hub. So that sync hub I just showed you a moment ago, let's create a connection to that hub so our web page knows how to connect to it. Then down here at the bottom, we're going to start that connection. And starting a connection is a multi-step process internally. It's going to figure out the best way for the client and the server to talk, and then it's going to establish that connection. Then you have all this stuff in between. We're going to set up a Signalr event that basically says whenever I get a message from the server that a new user has been created, it's going to pass me the metadata for that user, and I can add that user to my list of new users. Now, I have to be able to subscribe and unsubscribe from the events when I want. And that's easily done by clicking the buttons. Whenever I click on the start button, we're going to send the message to the server telling it that I want to start receiving notifications. Or if I press end, I'll get the button end notifications. This maps directly to our sync hub. Remember, I have start notify and I have end notify. So these are basically one-to-one naming wise. Now, that's a whole lot of description for something that should take an hour or two to describe. But let's go ahead and go into our Signalr example. We'll say .NET Run. we'll open a web browser, and I'm actually going to do two things here. Let's go ahead and open up DevTools. We'll hit refresh. So when the page loads initially, it's going to create that connection to Signalr. You can see it normalizing the URL, so it's all fully qualified. When I say connection.start and I ask Signalr to figure out the best way for it to talk, it's actually going to go make a negotiation call. We can see that right here. Signalr and the client and the server are going to talk, and they're going to say, what's the best way for us to communicate? And ideally, that's going to be a WebSocket. But there are other ways for Signalr to talk if you don't have WebSockets available. So for example, if you're behind some proxies, some VPNs, there's some cases where just network-wise, it can't support a WebSocket. If you can't use a WebSocket, there's two fallbacks. There's server-sent events, which is a very Netscape era way to solve this problem. It works perfectly. And then you also have long polling. And long polling just is, if we go back to IE6, IE6 can still support long polling, no problem. It's basically just making AJAX requests that are long-lived until the server needs to send messages down to the client. Again, this is like a 15-minute discussion in the course, so I can't really go too deep into it right now. But best case scenario, you get WebSockets, and the client sets up that WebSocket connection back to the server. You can see WSS for WebSocket. And Signalr is going to manage this connection for you indefinitely until something physically severs that connection or the web page goes away. And we can sit here and we can look at the messages coming down that pipe. They're just JSON. The type 6, that's just a heartbeat that Signalr is sending on our behalf to make sure that everything's good to go. I'm going to hit start notifications, and we can see my call to start notify went up to the server, and we're just waiting. And I just got a message from the server that there was a new user, and there's all the metadata for that user. Well, my event handler picked that up, added the entry to the unordered list. And it's just going to sit here and keep waiting. Every 10 seconds, it's going to get that new user notification. I can duplicate this tab a couple ways. So let's start notifications. Let's put you down here in the corner. We'll say start notifications, and we'll say start notifications. So let's just sit here and watch these for a minute. You'll see that they all got Matthias at the same time. They're all getting the state update from the server until they just don't want to receive it anymore. Let's see, Elsa, we'll stop notifications on that particular window. We'll wait another moment, and everyone else should get Caroline. All right, so Caroline is in these new windows. The state is still changing on the server. We just elected in that one window not to hear it anymore. So you could use this to your benefit to basically sync any state changes the server knows to the individual clients that need to know about them. We're all good on time. So I'm going to show you a real life example of one of my favorite Signalr apps I've worked on. I actually do a separate talk just on this particular client. It's a nonprofit I worked with a long time ago, but everything underneath the scenes here is Signalr. So this is called LiveCAD. And LiveCAD is a 911 aggregation site. And what it's doing is it's taking 911 data from a variety of different agencies. This is Southern Ohio. And it's combining them into these lists that are called configurations. So a variety of different cities and counties are sending data in. We're aggregating them all here. So you can actually see this is the Fair is one county, MEC is another county, West is another county, LCRR, RCC is another county, or another agency. So they're all sending this data and we're combining it into these different views. And this is all done in real time. So we have some backend services that are collecting these updates from the agencies. It's figuring out the state of everything that's going on, and it's figuring out nothing's updating right now. So usually when I do this demo, stuff's updating left and right. But I guess it's not a terribly busy evening. 50, yeah, not terribly busy. Oh, we'll watch it for just a second. But it's processing these updates in the background, and when something changes, so it's added, changed, or deleted, we figure out which of these configurations need to know about that update, and we send the update directly to them. So the short story here is that when I originally came onto this project years and years and years ago, this entire view, it's updating a little bit now. So some stuff's going away. You can kind of watch some of the trucks over here, their statuses are changing. When I originally came onto it, it was a single server running IIS, ASP.NET Core, or I'm sorry, ASP.NET Framework web forms, and it had a database server all on one box. Every request that came in, we go to the database, it would figure out all the colors and how things would view, and then it would take that, send it back to the client, and because it was web forms, everything was inside of an update panel. So the way update panels worked in ASP.NET Framework is it would just re-render the entire page, send that payload, and just update what's inside of the update panel. Effectively, this update panel was updating every 1 second, and that was for everyone currently viewing the page, which was multiple hundreds, if not thousands of people. And let's just say that poor little server was 100% CPU all the time. And they said, Kevin, can you help us? And I said, sure. So we built a iteration of the application that didn't use web forms anymore. We moved everything to MVC and basically HTML, CSS, JavaScript. And we used Signalr to facilitate the communication between the clients and the server, and deployed it. Everyone went live on it. And the server was actually like 1% CPU, to the point where I didn't realize, I thought I'd broken it. It's like, oh no, something's not working. There's no reason it should be 1% CPU. And it was working just fine. It's just we had optimized so much of the process that there's just nothing for the server to do. It was waiting for work to come in, and it was waiting to send the responses out to people. So fast forward like 3 months after we had gone live with this system. Hey, all right, so real-time update. So something just literally happened. We got the information. So when it's flashing red, that's usually not good. That means whoever's looking at this view in real time needs to go deal with this. So hopefully that unconscious person gets taken care of. So actually, this kind of leads into the story of, it was a firehouse late one evening, and they have LiveCAD up on these big TVs in the firehouse so they can see what's going on. And the screen started flashing red like you just saw. The folks got their gear on, they got in the trucks. Trucks were out the door, and like halfway down the street, when the dispatcher came over the intercom and basically says, hey, we need you all to go respond. We have an unconscious person. They need your help now. Well, it was a matter of minutes between the LiveCAD notification and the dispatcher coming on. And the way I sum it up is like this. If you've ever dealt with a life-threatening ailment, so a heart attack or stroke, something to that nature, or you've had a family member or a loved one or just person you kind of care about have an issue like that, you know that there's a difference between seconds and minutes in getting that person the care that they need. So having used just technology to optimize a workflow, we were able to get emergency personnel to the people that needed their help faster than a physical person could tell them that they needed to leave. So if you don't get anything else from this talk, just know Signalr saves lives, and you should totally go learn how to use it. So with all that said, hey, don't forget, I have a course on Signalr, signalrmastery.com. You should totally go buy it. All right, let's wrap this up with number 4, something I think everyone should be doing is caching. And this has been around in ASP.NET forever. You've had output caching. But with ASP.NET Core, so let me back up. It's always been an ASP.NET framework. You had output caching. Now with ASP.NET Core, we have a little bit more flexible caching structure that's probably a little bit better for our applications. Now let's talk about caching in general. We have our applications living out there on the internet. We're talking to a database, and we need to go to that database and get some data. Now, SQL Server is fast. It can be fast. And if it's slow, it's usually because you actively work to make a slow call, or you're storing 10 million rows in a database and you decide to pull them all back, or you don't have proper indexing set up. There's a variety of reasons a SQL Server could be slow. But I mean, if you're making frequent calls, it's going to eventually speed itself up through just some internal devices. But let's just say you're going to get data and it's going to come back and you're repeatedly getting that data. And it's a significant amount of time to get that data back. And that causes an issue. What if there was a slightly better way to store that information that we're going to the database for just kind of off to the side? And whenever we need it, we can just take what we know and send it off and not have to make that round trip to the database. That's essentially what caching is. A request comes in, we go to our cache, and we send the response back. So as long as we have a series of rules that dictate how fresh data actually needs to be, how often it changes, we could keep stuff in memory, just in RAM, kind of indefinitely, and be able to respond to these requests extremely fast. So if we compare the first example, maybe it's 200 milliseconds to go to the database, and then it's another 50 milliseconds or so to return a response. If we were using caching, maybe we could do that entire thing in under 50 milliseconds. There's a lot of benefits to caching if you have heavily used APIs or different endpoints. So this is more about the general concept of caching, not specific examples. There's also a case where maybe you're running multiple servers in some sort of load balance set, and they can all use distributed cache. So Redis is kind of the de facto standard out there. There's also in-cache, which is really good. I've used in the past. But what if your message comes into your server and it goes to Redis cache, which is almost just as fast as being in RAM, gets that data and sends the data back. And because it's in Redis, that's predetermined cache can be used by any ASP.NET Core app in your load balance set. So nodes can be added or removed independently, and they can always go to the same cache that gets that data. Now folks do like entire talks on caching, on using Redis intelligently. I don't have the luxury of going that deep into it, but I want you to think about caching as just a series of key value stores or a dictionary as a really good way to look at it. And so let's think of it like this. If I'm caching user profile information, not necessarily something that changes often, it's just maybe the user's name, address, phone number, email address, so on, so on, so on, or the roles that they currently have. That's data that I want to persist indefinitely in the database, in SQL Server or MySQL or Postgres, and I need the database to be authoritative. But I also know that stuff doesn't change very often. Like the roles I'm assigned to aren't going to change that often, and when they do, I know about it. So wouldn't it be nice if I could put user data in a cache? So if I just need to quickly check to see what their roles and permissions are, I can go to the faster database, Redis or in-memory, check that, and then get back to what I'm doing. So I could say, well, let's store the data for user 8675309, and that's going to have the object, maybe a JSON string for the information for Jenny. And I can go check that user anytime I want to because the key is repeatable. If I know I'm logged in as user 8675309, I could just quickly go look that data up in the cache and get the data back. So essentially, this comes down to a string key getting back to a string value. It actually gets a little bit more complicated than that if you go deeper, but this is just a generality. In ASP.NET Core, we have a couple ways to set up caching. The first one here I have is add memory cache, and that's for a single node, single instance of your ASP.NET Core app. If you put something into a memory cache, it's just going to be on that server. It's going to be crazy fast, and it'll be on that server. It also doesn't necessarily need to be a string. You can put entire objects into memory cache, and you don't need to worry about the serialization of it. Of course, there's very few cases where I probably use memory cache directly. I much rather use a distributed cache, and we have two types of distributed cache. First is add distributed memory cache, which is, okay, this is basically for unit testing or test examples. It's distributed. It gives you the interfaces for distributed caches, but it's not really distributed because you're not actually connecting it to anything. If you're setting up unit testing and you need to test a distributed cache, you just use this, and it all works magically. But everything's in memory. This one process is not shared between all the different processes. But if you add a distributed cache provider like Stack Exchange's Redis cache, you can tell it, all right, let's use distributed cache, but we're going to connect to this Redis server, and anytime you need anything, you're going to go to that server. So, all right. Sorry, one of my kids came to the door. So, all right, where was I? So we set up Redis, and every time we ask for something out of the cache or to put something in the cache, it's going to go to Redis, and everything's great. So let's see an example in motion. So here's a sample controller. We can inject the cache pretty easily. So here in my controller, we have, or our constructor, we have iMemory cache, which is the interface for injection. And we can see right below that, I can set a value by giving it a key and then passing in the object that we want to be represented by that key. And then later on, if I need to get the object back, I can say, all right, well, let's get the object. Here's the type I'm expecting. And here, what's the key of the object? And again, this is all happening in memory. It's all local RAM. We're not actually going off to Stack Exchange Redis to do that work. Distributed cache works similarly. We're going to inject it, but it's not going to be iMemory cache. In this case, it's going to be iDistributed cache. iDistributed cache could be, if you're unit testing, could be in memory, or it could be talking to Redis cache. There's also providers for other caching systems if that's what you're using, but it's a similar concept. And one thing I'll notice here is I forgot to put in a await on set async. That should be awaited. My bad. But again, I'm giving it a key and I'm giving it an object. And you have some helpers with distributed cache that will serialize this to JSON essentially, or you could just pass in a JSON string yourself. The key thing to remember with distributed cache is everything needs to be serializable. So don't use any types in your objects that aren't serializable. So like, trying to think of a type off the top of my head. All right, I'm failing on that, so let's not worry about that. But if it's not serializable, it's not going to work. It's going to throw an exception. But if it's serializable, like numbers, strings, dates, all that good stuff, you're fine. ASP.NET Core will automatically take care of the serialization for you. Or you could do the serialization yourself to either a string or to bytes if you want to get fancy about it. So Pulling from the cache is the exact same thing. You want to get async from whatever key you have, and it will go get that data and pass back the result. And the results normally go and come back as a string, so you might need to parse that object. But let's show a real example, because I actually really like this demo. Let's go into our caching app, and I'm just going to run it first. So .NET run. Oh, let's close that one down. All right, so this is my app, and I have a controller called the Pi controller. And what the Pi controller does is it calculates pi, basically. Let's see, let's go ahead and say pi. And it's going to sit here and it's going to crank for a minute. At least I think it's cranking. Yeah, I'm pretty sure it's cranking. The defaults are pretty beefy. So we'll give it a second to run. Let's look at the code. So the defaults I have is let's calculate pi to 25 digits. And let's do 10,000 iterations by default. It's going to go through and do all that work to figure out what pi is, but then it's going to store the results into a cache. Oh, I want it to complete first. Here we go. All right, so it's not putting the period in there, but it's 314, so on. There's a lot of digits of pi, and that took 15 seconds if we look at developer tools. But I'm going to hit refresh, and that same request that took 15 seconds before now takes 7 milliseconds because all this data is stored in our cache. So let's see what's happening. When we come in, we're going to figure out what the key is for the request. And we can figure out, all right, pi to 25 digits and 10,000 iterations. Our first goal is to check the cache. Does that key exist in the cache? Let's assume it does. Well, if it does, I'm going to take that result and return OK. Boom, 7 milliseconds, we're done. If it's not, we're going to have to do a little bit of work. Let's create our pi calculator. Let's go get the digits of pi, passing in the things that we know. We're going to wait a moment. Whenever that result returns, we're going to go use that same key. We're going to pass in the data that we get back. So here, I'm not actually passing it as a string. I'm passing it as a byte array. No big difference on that side. But then I'm also telling the distributed cache, I want to set a TTL, a time to live, or an expiration on the cache item that says this cache object should live no longer than 1 minute from now. We can get crazy with expirations. We could set absolute expirations like I did here. I can set up sliding expirations that say, all right, well, every if I access it, push the expiration another 30 seconds or another 30 minutes or another 30 years. We can be pretty upfront about those time spans. Once we put stuff in the cache, we're going to return our result. That takes 15, 16 seconds. Then we can rinse, repeat. Now, I don't think I have my Redis. Oh, I don't. So I had to rebuild my machine a couple of weeks ago, and I forgot to install the Redis tool that I wanted to show you. Because I would actually show you all this stuff in the cache, but I don't have that, so sorry. So we can go through and say, all right, well, let's do 50 digits, but only do 10 iterations. All right, that one was crazy fast. But it's half the time if it's cached. Let's do 10,000 iterations. All right, that one's a little bit. Let's do, here we go. Here's a little bit. I want something with a little bit of beef behind it. So we can watch this down here. It's still pending. Pending. All right, 14 seconds. See, I feel like we should do a little bit more. I want a beefy one. I had an example when I was building this demo. That was like 3 minutes, and then when you did the cache version of it, it was like 5 milliseconds. It was great. Such a good demo. All right, so this is cranking. I'm actually not sure how long this is going to take. Hopefully it's not crazy long. Pending. All right, this might be a little bit more than it can chew at the moment. This is not the most efficient pi calculator out there. But let's use this. So we have 10,000, should still be in cache. Oh, so 54 milliseconds, okay? If I refresh, it now takes 6 milliseconds. That's a huge difference in time. And if folks are hitting this endpoint over and over again, 6 milliseconds is drastically better than 54 seconds. Heck, that's drastically better than 14 seconds or drastically better than 1 second on endpoints that are getting hit over and over again. Now, if it's an endpoint that only gets hit like once every hour, maybe not a big deal. It's not something you want to optimize or cache for. But if you have stuff that gets hit over and over again, totally worth taking the time to optimize that for cache. We do this on things like country state data. We have a list of countries that we nurtured to and the states associated with them. That stuff doesn't change very often. And if it does, we could just reboot the server so we get a fresh cache, or we can remove the data from the cache. There's ways to get that out of cache without having to do a lot of heavy lifting.
Kevin, there's a question in the chat. Can you force invalidate an entry? I think that's sort of what you were talking about there. If you have something in cache, how do you get it out if it's not valid anymore?
Yep. Basically, if you know the key, you can delete the key from the cache. That's the easiest way to go about it. And that's what I would do. So let's say I have a case with let's go back to Jenny. Jenny's probably a better example. If Jenny her permission changes, well, I know about that on the server when the action occurs. So I can just go and validate the cache, and the next person that needs to look at Jenny's permissions will see it's not in the cache. We'll go to the database, get the permissions out of the database, and repopulate the cache from the new data. Very easy to do that. So always assume your server knows what's going on. So if it knows something changes and invalidates the cache, you can go and invalidate the cache automatically. There's also a lot of really cool stuff I've seen people do with like any framework where you can add a caching layer in front of your database. So any framework knows if an entity changes in a way that would invalidate the cache, and it would automatically invalidate the cache. I don't do a lot of entity framework, so I can't really point you to any examples, but I've seen folks do that. It's really easy to get creative with caching. But the biggest thing that you run into is when you have something in cache that you don't expect to be in cache, or it's in cache longer than you expect it to be, or the state in cache is different than the state in the persistent database. Again, that's why caching is kind of left to its own talk altogether. But I've been talking long enough where if I hit this endpoint again, it's not going to return in 6 milliseconds. That's because my cache invalidated itself, and now it has to go through and recalculate all those digits all over again. Theoretically, I don't have to set expiration dates on this data because pi doesn't change. Like pi stays the same every single time I compute this. But I put the expiration on there for fun. All right, so this is going to crank for a couple seconds. Hey, there's that edge bug again where it's negative loading. I'm not sure what causes that. But all right, everyone. So that's my 4 examples. If you like to see any of the source code for the demos I've done today, you can go to my GitHub at 1KevGriff, Supercharge ASP.NET Core, and everything's there for you to download, install, and run. I try to keep everything pretty concise in the demos themselves, just show off the features and not try to do anything special. I see that way too many times with a lot of applications and demos out there where you just want to see the one thing and you have to go through all the crud to get to that. But with that, thank you all so much for hanging out with me today. Don't forget you can reach out to me on Twitter at @OneKevGriff or go to my website, consultwithgriff.com. And if you're feeling nice, go pick up a copy of Signalr Mastery at signalrmastery.com. Yeah, I have a couple moments. Happy to answer any questions that you all have. If not, actually, I have a hard stop in about 6 minutes because I have to go take care of the kids. But thank you.
Well, thank you, Kevin. Any questions in the chat? Yeah, I don't so much have a question, but the health checks is something I'm definitely going to be looking into. We've undertaken a project at work to put together a dashboard like that for all of our services. Be able, so we can at a glance see where we're at, and I think that's something we can definitely implement there.
Yeah, definitely. Actually, and there's a use case where you want to combine health checks with caching. So if you have a zealous health checker, or you have a lot of health checkers, it's possible to DDoS yourself with health checks. I've seen it done once or twice, but that's something that doesn't happen that often, but I've seen people do it.
Okay, we just had a question come in the chat. Can you use Signalr for a real-time game?
Yeah, totally. There's when you say real time, like there's of course a scale of real time. I wouldn't use Signalr necessarily for like a twitchy game, like a first person shooter type thing, just because you do have a little bit of latency and overhead. But if there's actually a couple examples out there of folks building like little space shooters using Signalr, and those work extremely well because you can take that input from the keyboard or mouse, you parse it into a little bit of JSON, send that over the pipe to the server. Server turns around, updates the game state, and then updates all the different clients. I had an example I was working on a long time ago where I was building a multi-user dungeon of mud with Signalr, and it's the same concept where basically you go to a web page, you'd be dropped into the world, and you would send your commands over Signalr real time back to the server. So I've seen people do that often. But if you need, like if you're doing like a Fortnite, let's go old school, like Quake or Doom style game, you probably want a little bit lower level network. You don't want to use Signalr for that. The other common question I get with Signalr is, can I do real-time video with it? And the answer that's no. It's not designed for that purpose. Because essentially everything you're communicating over a WebSocket is going to be, most common case is going to be strings. There's also, it can talk raw bytes, but it's not as efficient as using actual video codecs. All right, friends. Well, it's been fun.
Okay, thank you very much.
All right, y'all take care. Have a great night.
Thank you as well.